Hi everyone, thank you for being here tonight. My name is Henri, I work at Starkware and I'm a dev advocate for Starknet. So it is actually falling, I'm not dreaming. Okay, so so my job is to explain to people what Starknet is and what kind of cool stuff they can build on top of it. I actually have two presentations, I'm not sure yet which one I'm going to present, so let's just make a quick row of hands. Who here feels relatively comfortable with how ZK rollups work? Okay, who here is totally new and would like to understand how these things work? Okay, fair enough. So I'm going to make a presentation that is a bit more technical, meaning I'm going to explain why people are excited about ZK rollup. I'm not going to go exactly into how they work, but if you're interested into that, do come and see me afterward. I'll be more than happy to catch you up on the thing and explain how it works. So the goal of this presentation, I've presented it a few times already, and after spending some time in the ecosystem, I see many developers come to Starknet and then try to build stuff and get really excited about one thing or another. What's funny is that it's really different from people to people. Some people get really obsessed about one key aspect and totally neglect other features. And other people are really excited about these features and not the others. So I'm going to outline 5 things where people usually get excited. People rarely get excited about all 5s. But usually at least one clicks. And what's funny is that you have builders from the space using all of these features, most of these features here today. So you should reach out to them if you have questions. Okay, so the first thing people get excited about ZK rollup is usually cheap computation. So a ZK rollup essentially allows you to have a network that is both decentralized in its trust model, meaning that all actors can run small computers and have extremely strong guarantee of the calculation that is done on the network. But you get to do that on a network where execution is executed on big machines. It sounds counterintuitive when you're coming from the traditional blockchain world, because usually it's the other way around, right? The bigger the network, the more powerful the network, the less decentralized it is. Here you get to have the best of both worlds, right? Thanks to the divergence and the asymmetry between provers and verifiers. Now, having execution of code being outsourced, kind of like how security is outsourced in a proof of work network, means that your network can actually use the power of a supercomputer inside of its smart contract. So what can you do with that? Why is that exciting to people? Well, usually it comes in 2 flavors. The first one that is obvious to everyone is that ZK rollups are cheap, right? You get to do a lot more transactions in the same block, so you can do a lot more of the same thing. So the unit cost per transaction drops, right? So you can do the same thing you used to do before, cheaper. But when you look at it from another lens, you can do more of the same thing, or you can do different stuff, but more complex. It's a weird analogy, but you can think of Ethereum as a bread toaster. You can put 2 slices of bread and heat them. It's pretty cool. ZK rollups and Starknet are like a oven. If you want, you can put a lot more bread inside of it and heat them at the same time, or you can make cake, or chicken, or clay pottery, whatever. You can do new stuff that you can't do on a bread toaster. You can do more complex things. And we're seeing a lot of traction and a lot of excitement around stuff like gaming. We see a lot of people who are starting to write games that have deeper, more meaningful interactions that are actually controlled and enacted on-chain in a trustless manner, so you get a richer gameplay. We get people obviously interested in AI, which is kind of this white whale, you know, the intersection of AI and blockchain. It turns out that it's actually theoretically possible to run neural networks on-chain with ZK rollups, and we're seeing people trying to do that. You obviously get people doing more interesting generative art than other stuff, and like generally the fact that you have cheap computation allows a lot of use cases, right? Okay, so that's the first topic. The second topic where people get really excited about ZK rollups is account abstraction. You have actually somebody from Argent here in the room, so you can ask him about, raise your hand so that people know it's you. Nice, so you can ask questions if you have questions about account abstraction. So account abstraction is not a feature of ZK rollups per se. It's a benefit we get from standing on the shoulders of giants like Bitcoin and Ethereum. It's essentially at its core, it's a way of abstracting, it's a way of making transaction authentication part of the VM. Like think about it this way, when you send a transaction to Ethereum, it's authenticated at the network level and then it enters the EVM, right? This authentication brick is the same for everyone and it happens in the node, right? And you have to sign something specifically. What if this brick that is the same of everyone, for everyone, instead of having it outside the VM, you add it inside the VM? Well, that's basically it. Account abstraction is this in a nutshell. You turn authentication of a transaction into a programmable brick that anyone can customize. And you can do a lot of stuff with that. It bears a lot of promises for how people interact with blockchains. So you get all kinds of crazy ideas. You have people working on social recovery. You know, not your keys, not your coin. You lose your coin, you lose your keys, you're screwed. Here, since every account has its own logic, every account is a smart contract, so this means that you get to implement whichever logic you want. If you lose your key, you can add a rule that says that if after 3 months you don't interact with your account, then your grandma can unlock it. Why not? You could have very easy multi-sig you could implement. You could delegate signing to somebody for a short period of time so that you don't have to validate transaction always at the same time. You could batch actions together so that you don't have to do approve, transfer every time and then just generate a simpler flow for your users. You could also just abstract the network away. There's a live app today on Starknet, on mainnet, that has a few thousand users that are all using this NFT game on their cell phone. They're all holding their own key. Nobody can move their asset but them, but they don't pay for gas. All of this is abstracted away. The blockchain is abstracted away. So it is a really great door to rethink the UX and the relationship your users have with your application. So that's another big thing people get really excited about and it's account abstraction. Now the third thing people will get really excited about is the bridge Starknet has. And the bridge Starknet has two key components. The first one is that it's not secured by game theory, it's secured by mathematics. Meaning that when a message or when there is an information being exchanged between Starknet and Ethereum, this message is transferred by Ethereum actually understanding what happened on Starknet. There is no human in the middle signing a message saying, yes, this is what happened in block 100. Ethereum is actually able to understand outputs of block 100 from Starknet. To the best of my knowledge, it's the only context where you get blockchains natively talking with each other. And that's very meaningful. It means that you can start treating Starknet really as an extension to Ethereum rather than a separate network, right? And the second brick that allows you to build really cool stuff with that is that the bridge of Starknet is not meant to bridge funds. You know, when you think about bridges, you think about, oh, I'm going to move ERC20s, ERC721, which is nice, but very limited. When you think about it, you can do way more stuff than just move around tokens on the blockchain. Well, with the messaging bridge of Starknet, you're moving data. So you can really write a cross-chain application that allows you to design an application that has components on L1 and on L2. In other words, if you're an L1 application, you don't need to think as Starknet as another network with another pool, with another, like just a clone of L1. You can really think of it as an extension. You can add functionality to your L1 app through L2, and you can tap into the same liquidity pool that you have on L1, which is pretty cool. So we have Maker and Aave deploying their own bridge. We don't operate their bridge. They coded it and they implemented it. And you have people like Snapshot who are building Snapshot X, which is a way for people to vote off-chain, get the results counted on L2, and get the actions executed on L1, which is kind of convoluted, but really fun, right? And you could really, you can do a lot of stuff with that. All right? That's the third thing. The fourth thing is storage proofs. Storage proofs are something I'm not going to spend time on because you're going to hear about it in a second, but from Marcelo, right? This is probably a simpler view, so you'll pardon me if it's too simple. But storage proofs, in a nutshell, are something that is allowed by cheap computation. It basically allows you to have on Starknet data from another chain being imported in a trustless manner. It's a weird analogy, but I like to say it's CRISPR-Cas9 for blockchain. You can really take the state of any blockchain and import it in Starknet and then do whatever you want with it. So it's, anyway, I'll let Marcel talk more about it, but actually I need to put Herodotus icon here instead of fossil. You know, you could, for example, decide to generate a proof that some people hold some funds on chain A, then generate a proof that they're all part of this set on Starknet, use the bridge to transfer it back to L1 and use Sysmo to generate a set and a verifier that on L1 that all of these people are part of this other chain, all of this trustlessly, which is kind of cool. And the last thing people get really excited about is fractal scaling. So fractal scaling is, in a nutshell, the big brick that allows ZK rollup is provable computation or provable networks, which is essentially a way for one person to execute some code, Alice, and then to prove to Bob that she executed that code without Bob having to re-execute that code. Sounds trivial, but when you think about it, it's a fundamental paradigm shift as to how blockchains work today. Because in the blockchain world today, we want to agree on a given state. And the only way we have to do that is for you and me to execute exactly the same payload. Because there's no other way I can trust you. Well, actually, there's a new way now. I can generate a proof that I did something correct, and you can verify it. And the cool thing is that verifying it is a computation, right? So what if I verify you did it correctly, and I generate a proof that they verified it? And then I generate another proof that I verified it. You can actually nest these proofs quite deep, and this allows for a lot of variety in terms of how you build out your application or how you look at the network. What's really fun with fractal scaling is that the name is really good because you actually can apply fractal scaling or recursion in a lot of dimensions. It allows lowering latency in your network. It allows augmenting throughput. It allows building stuff like L3s on top of L2s. It allows building everything between L2 and L3. You can really go in a lot of directions with it. And it's a brick that will fundamentally affect how the topology of blockchain networks in the coming years. So it's a really exciting brick. And right now, there's a lot of people waiting for it. I know a few of are in the room are waiting for that, but yeah, this is why this is the fifth reason people get excited about ZK rollup. Where do you start? So I'm guessing who here is a dev or likes to code or knows how to code? Nice, a few of you, cool. So where should you start? I hope these links are good, are still good, but basically we have a few tutorials. So you are at this weird twilight zone where we're sunsetting our language, Cairo 0, and opening our new language, Cairo 1, which is going to be great and amazing, but is just out next week. So you can actually ask the people at Finiam. Can you raise your hand? They did a really cool workshop today, so they can guide you into good resources to learn about Cairo 1. If you're participating in a hackathon in the coming months or so, I suggest you go through these resources because Cairo 0 will still offer you good stuff to build on. But if you want to build something more long-term, definitely go with Cairo 1, and these links can help you. All right, and that's what I wanted to say. Are there any questions? Oh my God, I was so clear. Nobody has any question? Nice. Okay, cool. Well, thank you for your attention.